Hi everyone, hope you all doing well. So here in this video, we are going to analyze a challenging organic problem. Now just look at the given reaction. So as in the problem solving skills of organic questions, we need to look at the all possible reacting functional groups on reactant, and we need to look at is there any stereochemistry on the reactant, okay, and we need to look at the given reagent combinations, and we need to look at the reaction conditions, okay, that means heat or photochemical conditions or given or not. If you observe all of them and if you follow step by step mechanism, then I can say we can get 100% product of that particular reaction. That means we can get the correct product from that reaction and we can get 100% of marks from that organic question. Okay, right. Now, in the given reactant, we have ester functional group and we have double bonds and we have hydroxy group which is protected with MOM, and stereochemistry is given. Whenever the reactant is given with the stereochemistry, that means the reaction is a stereospecific reaction. Okay, the reaction is a stereospecific reaction. That means the product of the reaction decided with the stereochemistry of reactant. Okay, now we have given with LDA, so we need to look at the reagent combinations. LDA, we know that LDA is a bulk base, bulk and strong base which can abstract acidic protons. Okay, and second one here we have given with heat, so heating is given. So these are the observations we need to take from the given reaction, and why I said it is a challenging organic question, because all the four products are possible for the reaction. Then we need to pick the correct product by having basic conceptual knowledge. So that's why it is a challenging question. Are you ready to get the analysis of it? Okay. So before that, I'm very happy to inform you that we have launched a new version of mobile app, that is chemmasters.online, which is having all the best user-friendly features and where one can get exclusive chemistry courses with attractive fees only, and you can get the free content also. So hurry up to download chemmasters.online mobile app from your play stores. Okay, so thank you very much. Now just come to analyzing this challenging question. So I'm going to draw the given reactant. Okay, so here hydroxy group is protected with MOM. Okay, here is the methyl group above the plane and here is the hydrogen which is given as below the plane. Right, so we have given with LDA. We know that LDA is a strong and bulk base and which can abstract acidic protons. So which is going to abstract proton here, and there is the formation of enolate. Okay, so I'm going to draw that enolate as a first step of the reaction. So here is the formation of enolate. Right, now all the four products are possible from this enolate. Now how the first product is going to produce, we are going to check it. So here the enolate, if it is going to attack here and if the double bond moves here, and the electron density, if it is going to abstract proton from the reaction medium, then it is going to produce product 1. Okay, right, so just draw neatly step by step. Okay, right, the next case, how the second one is going to produce. So same, whenever enolate moves here and it is going to attack here, if we think, okay, if the MOMO, that is protector hydroxy group, is cleaved, then there is a possibility to produce second one. But in reality, is it possible? No, because hydroxy group is protected here with MOM, and then it is not going to cleave like this. Okay, right. So we need to look at the third one, how it is going to produce. And so these kind of possibilities are given to mislead the student. Okay, most of the students, more than 90% of students, without trying any mechanism, so they will just choose the options blindly if the options looks like attractive, and if it just looks like involving rearrangements and etc. Okay, so it is better to try step by step mechanism, then only one can get the correct product of a given organic reaction, and one can get a good score from that organic reaction, and what we say from that organic chemistry part of that competitive examination. Okay, right. Now how 3 and 4 are going to produce in the reaction? So simply whenever the enolate, okay, whenever the enolate is going to attack here, then the double bond moves here, the bond breakage takes place, so the carboxylate and ion abstract proton, then it is going to produce 3 and 4. What is the difference between 3 and 4 here? So simply the stereochemistry difference is there. Here in 3 we have cis relation between carboxylic acid functional group and hydrogen, whereas in 4 the relation between these two is trans. Okay, we can simply eliminate first and second products because here we have given with heat. So whenever heating the reactant here in the given reaction conditions, simply the heterolytic bond, the carbon oxygen bond of ester functional group is going to cleave easily when we compared with carbon carbon bonds. Okay, so that's why by having the basic knowledge we can simply eliminate first and the second products. On heating, it is possible to cleave carbon oxygen bond easily. So the ester cleavage is going to take place on the reactant on heating. So that's why we can simply eliminate first and second product. Okay, right. Now, so the answer must be in third and fourth. How it is going to produce? So we are going to check it. So draw the reactant again. Here I'm just drawing the enolate of that means what we say enolate here, the second step of the reaction. Here is the methyl group, and here is the hydrogen. Here is the protected hydroxy functional group. Right. Now try to label the carbons here 1, 2, 3, 4, 5, and 6. So whenever the enolate carbon is going to attack on the sixth carbon, then this double bond moves here. The cleavage of carbox, that means carbon oxygen bond, takes place of this ester functional group. So the negative charge on this carboxylate abstract proton from the reaction medium and produces the products 3 and 4. So how can you say it is going to produce 8-membered ring here? So just to try to label the carbons of the complete ring. So here you can get 1, so which are going to make a new ring, right? 1, 2, 3, 4, 5, 6, 7. Here is the 7 and here is the 8. So here is the formation of 8-membered ring. It is better to label the carbons or atoms which are involving in that particular rearrangement reaction. Then it avoids the confusion to you to give the correct rearranged product. Okay, so the bond cleavage takes place here and formation of a new bond here. Okay, right. So here we can get 3 and 4 as the product. Then what, so simply we can say that answer is in between 3 and 4. Here the final conclusion depends on the stereochemistry, that is the stereochemistry and the reactant which directs the rearrangement here. Okay, so we can say here 6 atoms are involving, so the ester cleavage takes place here. That means the rearrangement of that cyclic, that's what we say, the rearrangement of enolate ester taking place with the 6 atoms on heating. So we call this rearrangement reaction as ester enolate rearrangement reaction. Okay, right. Now, how the stereochemistry is specific here, how the stereochemistry is directed for the groups carboxylic acid and hydroxy groups. If we find that, and we can conclude the final product. Okay, right. So, here the enolate carbon. So, here we have bulk methyl group and bulk OMOM, which are above the plane, and here is the small hydrogen which is below the plane. That's why the carbene ion, or this electron density, carbene ion electron density is going to attack this carbon from the below side. That means from the less steric end. Okay, in bottom side of the plane of this reactant molecule, a small hydrogen is there, but at the what we say, at the top of this molecule we have bulk methyl group and bulk what we say, OMOM. Okay, protected hydroxyl group. That's why it is better to attack this carbene ion, or what we say, the enolate, from the bottom end onto this carbon in a concerted step. So whenever that happens, so simply the cleaved carboxylic acid functional cleaved what we say, carboxylate, and after abstracting proton, so carboxylic acid functional group, the cleaved carboxylic acid functional group should move above the plane on that concerted rearrangement, and this attack is from the bottom end, right? So that's why the hydrogen just moves above the plane. Here hydrogen is moved to top of the plane, and also the carboxylic functional group which is also moved to top of the plane. So so finally we conclude that hydrogen and carboxylic acid functional groups are same side, and they are above the plane of the product. So we can simply conclude that third option is the correct product for the given reaction. In a fourth, hydrogen is given backside. That means attack is given as from the top of the plane of the given reactant, but it is sterically crowded. That's why it is not favored. So third product is the correct product, and simply that is the stereochemistry is directed by the stereochemistry on the reactant. So that's why we can say that it is a stereo-specific rearrangement. Okay, right. And so please, once again, I'm just informing with that. So just download chemmasters.online mobile app and get the best ever chemistry content to get the success in your dream examinations. Thank you very much.